Yeah, thank you so much for coming. We know it's a hard time now after lunch, but we will do our best so you can enjoy. Well, he is Joan Sala, I am Jordi Rivera from ICATMAR, and we are going to present you the information systems we've built for fisheries management, from the data collection part to the web visualization. Now, imagine that you are in an Amazon rainforest, like this one, and you want to know the health status of this rainforest. One way of doing that, although it would be quite time-consuming, would be going to this forest, counting all the trees that are there, measuring them, seeing which is the health status, and then coming back the following year to do the same and see the evolution of it. So how can we do a similar thing on the marine environment, which most of the species who live there are like high mobile, and also it's an environment that is difficult to access for us. For knowing that, we have to know a bit more about the life cycle of most of the marine commercial species. In this case, we are going to take this kind of shrimp, which is called the blue and red shrimp. It's really tasty shrimp. And we will start like from the bottom left. So in this part, there are like the juvenile shrimps, like the ones that are still growing, and they will reach the adult phase at some point. At this point, they can get reproduced and they can generate eggs that will turn into larvae and then into juveniles again. So in this life cycle, there's many reasons for which a shrimp can end up the life before it should be, like for natural causes. These reasons could be like fisheries, could be predators, could be effects of climate change, etc. So our goal from ICATMAR is quantifying all that. So we want to know how many shrimps are out there in the sea. We do like experimental campaigns experimental fishing in order to know like how many shrimps are out there. We want to know the biology, like to know when they get reproduced, how fast they grow, and also we want to know the impact of fishing, to know if we can still fish at the same amount or we should take like some management measures. So having all this data and thanks to mathematical models, we are able to say the status of this shrimp, if it's in good condition or not, or we should do something. So who's behind that? In ICATMAR, we are the Catalan Research Institute for the Governance of the Sea. It's a cooperation organism between the Catalan government and the Institute of Marine Sciences in Barcelona. And we are located in the northwestern Mediterranean. And our main goal is like generating data, collecting data, processing it, and analyzing it for giving advice to the government. And on the other side also, we give recommendations to fishers on how to make like more sustainable practices. We are a multidisciplinary team of more than 30 people. And one of our goals as well is transferring all this scientific knowledge to the different stakeholders, which are the administrations, the scientific community, and the fishers and the society in general. So we will, in this presentation, we will go through this diagram, which I know you cannot see it very well, but we will go like chunk to chunk to explain which is the data management workflow that we are following for giving fisheries advice. So let's start with the data collection part. We go on board of the commercial fishing vessels, like the bottom trawling ones, which we are going to focus today, is the left one. This is a kind of fishing that is performed during the day, and it fishes like species that are associated with the sea bottom, like shrimps, lobsters, hake, etc. Then we have the pure seine, the middle one, which is fished during the night and mainly is like sardine and anchovy. And then the third one, which are small scale fisheries, which are like small vessels, targeting like a bunch of different species. So in all of them, we have like 20 biologists in our team who are going on board almost every week, all along the Catalan coast at different times of the year, and also they fish at different depths in order to collect data. So this is an example of what we do on bottom trawling. So this is the moment that what the vessel has caught arrives on board, and what we do is like identifying all the different species that appear there, which are like a bunch of different species. They can be up to 200. And we measure them, and we also track the fishing operation with a GPS device. Also, we take a fraction of these fish, and we take it into the dissection laboratory to know more about the biology of the different commercial species, and also which ones are discarded because they don't have like commercial interest, and also the marine litter, we characterize it. So how do we ingest all this data? We have developed a Django website, a data input website, that all the different fishing cruises are entered into this website. Here you can see like an example of them, and you can enter to any of the fishing cruises. You have all the information, so all the different biologists who go on board, they introduce this data as well. And you can upload a photo of each one of the fish, the howls, and also you can upload a GPX file. This GPX file will be visualized in a leaflet map and together with the positions that are taken manually on board. So once the positions are introduced, also this track is cut exactly to have the moment that has been fished. So then some data is extracted from here, like which is the distance of this track and which is the whole area covered. And this is the way we have of standardizing all the data. In this part, we introduce each one of the species that appear there and all the measures, so we also are able to visualize this data that the people is entering. So during this whole data input process, there's like different visualizations that can help the biologists in order to have the highest quality possible on the data. But our aim at the end is like having all the data stored in a PostgreSQL database with the extension of PostGIS with the highest quality possible. I mentioned all the technologies we are using, like Django, Python, JavaScript, Leaflet, and also Chart.js for the chart visualization. Then let's go to the external sources.
Hello. So now we have been talking about what we call internal data sources, which is mainly our sampling. But now I'm going to focus on other data sets that we also use and we also introduce in our database system. We call them external data sources. And I'm going to talk mainly about two data sets. The first one is the Vessel Monitoring System, or VMS. This is a satellite-based positioning system, and here we get the position, the course, the speed, and the timestamp of every vessel in our fleet, because this positioning system is mandatory for most of the fishing vessels in our zone. So with this data set, we try to answer the question of where are the fishing vessels actually fishing. And then I'm going to also talk about the other data set, which is the daily landings one. Here we have information on the sales that every vessel in our fleet is doing every day. So we have information on every species that is sold at the fishing auction, the kilograms, and also the economic value of this sale. So you can imagine that mixing both data sets is really powerful for fisheries management, so knowing where and what is being fished. And we can answer a lot of questions with these data sets, but we have to process this data before, and that's what I'm going to explain now. At the end, we want this data to be in our database system too, and for VMS data, we start with the data validation, and we do it through QGIS and R to get rid of some errors that we can find in our data. And then after that, what we do is the point interpolation. This is the step that we do because the raw VMS data, it comes with an average point frequency of 2 hours, which is a lot. And what we do is, using some algorithms, we increase this frequency to 10 minutes. So at the end, we have more spatial resolution in our final outputs. And here in the blue map, it's really small, but you can see like a fraction of the trawling fleet and these raw positions of this fleet. And after this interpolation, here it comes like the key point in this workflow, because a simple position, it doesn't say to us if the vessel is fishing or it's navigating or what is the vessel doing. And what we are interested, obviously, is in the moments where the vessels are fishing. So what we have to do is applying some fishing filters to the data. In the case of trawling fleet, it's kind of easy because these vessels are fishing in a very specific speed range. So if we just apply speed filter, we can retain the fishing positions. And this is the second map that is very small, but some difference you can see between the first one and the other one, which is the data already filtered. And this is the case for the trawling fleet, but as Jordi said, we have other vessels fishing in different ways. And most of them perform more complex fishing operations, so we cannot identify them just with a speed filter. We have to use more complex methodologies. And now we are training some machine learning models to be able to identify these fishing positions. And this step, we do it with pandas, GeoPandas, and scikit-learn, which is a Python package for machine learning models. And at the end, we introduce these fishing positions in our database. Then we do the same with the landings dataset. And once these two datasets are introduced in our database, there are some trigger functions that are activated. And these functions, what they do is mainly mixing both datasets. So at the end, what we have is a final data table with each position, and the corresponding landings in this position. So the kilograms and euros of these landings at every position. This is important because this workflow is time consuming. So at the end, we need the final data for a lot of things, and we will be querying a lot this final table. So it's a way to optimize all the data analysis. So what can we do with this data when it's already prepared? We can do this kind of maps. Here you can see what we call fishing effort, which at the end is the fishing time by square kilometer in our coast. And here you can see how the different fishing grounds are well defined and the fishing intensity in each of the square kilometers. And as we have this data together with the landings dataset, we can also do these other maps where you can see the landings. We can put the landings in the space, and we can do the same also with the economic information. So we can kind of estimate the amount of euros that have been extracted from a specific area at the sea. And we can do this with all the species together, but we can do this species by species as well. And here we come back to our species example, the red shrimp. And here you can see the fishing grounds where this species is caught. And you can see the difference of the last map with respect to the other ones, and see how the distribution of this species is really different from all other species together. And then, okay, we have collected all this data, and then we store it in our database system. Here you have some numbers in summary of what we have in our database. On the left, you have the sampling data. We have data from 2019 to 2023. And we have performed about 1,500 different samplings. We have covered about 4,000 kilometers in our coast. We have measured about 450,000 individuals of about 500 different species. And on the other side, you have this external data. We have here historical data, which is very interesting, from 2002 to 2023. And we have about 170 million points for VMS data, 50 million for landings data, and some other information of the fleet. And all this together, it's 450 gigabytes of information. So we have all this data in our database, and now we have to do something out of it. We have to answer some questions on fisheries management. And then what we do is, obviously we can connect to the database through many different applications, such as R or QGIS, and we also use Python scripts. And now I'm going to explain you a short use case of what we use this data for, which is the marine protected areas monitoring. What we do here, and you can see in the maps, is the monitoring of the fishing effort before and after a protection of a specific area. And you can see how after the protection, the fishing effort is removed from the zone. We can do this also through maps, but obviously we can quantify it, for example, year by year, and have the evolution of the fishing effort inside these areas. And we monitor what is happening inside the protected zones, but we also monitor what is happening around them. This is important because when we protect an area and we remove the fishing effort from a zone, this fishing effort can go somewhere else, so we can be impacting another zone as a consequence of the protection of another one. So we have to monitor somehow what is happening with the fishing effort and where is the fishing activity going. So what we are doing now is we draw these kind of buffers around the protected areas, and we quantify the fishing activity there before and after the protection to see if there is any difference and see how the system is responding to the protection. And now, Jordi time.
So the last part is, I said at the beginning that it's important for us transferring all the scientific knowledge to the different stakeholders. So what we've done is deploying a website. You all can access to it, ICATMAR.cat. In this website, you will find all the information about who we are, what we do, and not only the fisheries side, also the operational oceanography side with sea surface currents and all that. But now I'm going to focus on the visualization part. So we have developed a fisheries viewer, and the architecture behind it is we have developed a backend in Node.js that is querying the database and is serving data to the front end, to the visualization part. That the front end is mostly developed in Vue, JavaScript, OpenLayers and D3 for the maps and charts. And we also serve some rasters into this visualization part that we generate through QGIS and GeoPandas. And finally, we retrieve some marine habitats information from EMONNet and also some environmental variables from Copernicus. Those ones are served through WFS and WMS. So now one example of the visualization part. So it's only bottom trawling and the sampling that we are performing, but here you can access like at each of the ports that we are sampling. For example, in this case, Barcelona, which are the species that are being fished and commercialized, which are the species that are being fished and discarded because they don't have like commercial interest. And this is the marine litter. So which is the marine litter that the fishers are extracting from the sea bottom. And in this case, in Barcelona, half of the marine litter extracted by the fishers are wet wipes. So on the other side, we have the geolocalized fishing catch, which on the background you can see the maps that Joan was explaining before that he's generating about the fishing effort, the amount of kilos per square kilometer and the amount of euros per square kilometer. And we overlap this information with the sampling information. In this case, it's a fish of blue and red shrimp, again, that has almost no marine litter and is at more than 500 meters below the sea depth. And we combine this information with the weather and sea conditions of that specific day and position. And this is an example of a different howl, like at different depth and totally different composition of a species. And we finally are able to combine this information with environmental variables from Copernicus. So this is the sea surface temperature, this is the temperature anomaly, the chlorophyll, and the currents. So you can select all these environmental variables and they are retrieved on the fly from Copernicus WMS services. So we are analyzing the web traffic of this website and the visualizers since we launched it a bit more than 1 year ago. And we found out that 40% of the users are accessing the website and the visualizers through the cell phone device. So we adapted the user interface of both in order to make it more user-friendly on the cell phone devices. And that's it for now. I hope you found it interesting. Here you have our emails and our GitHub repository. And we are here if you have any answers. And thank you.